trick 2, right? Okay, so trick 2, girls, is a lot of proofs, like a lot of deriving. You'll definitely need your log tables, and you'll need them open on page 13, 14, there's loads of identities on 14, 15, yeah. So 13, 14 and 15 are going to be your go-to pages for the next week and a half, okay? So, by the way, girls, you have no test next Friday. We might give you some problems to do. It depends on how I'm going with the chapter, okay? But you won't have any test this Friday. And have you been told anything about your pre's? Anyone?
No.
No.
Okay. No.
Nothing?
No.
Right.
Not a thing.
Yeah, I would imagine they're not happening, okay, but I'm no expert, okay, but I would imagine they're not happening because I don't know, we'll be back at school, sure. Is it tomorrow they're going to tell us everything, is it? Or Wednesday, I don't know. Nobody knows.
That's true. Mr. O'Regan said Mr. Cregan will probably make a decision after that.
Oh, right, okay, so, yeah. So I would imagine, yeah, it depends on whether we're going back to school or not, like, but even if we do go back to school, I don't know, are we going to, like, waste 2 weeks doing pre's? I don't know. I actually don't know. I know it's worse for you. Probably those 3 words are probably just causing so much stress. I'm sorry, but, you know, I can't answer it. But look, I'll talk about this week. There's no, you know, the way we said we're having a test every Friday, you're not having one this Friday. End of. Right? On to trick 2.
I know. We'll be having a class.
Can I answer that as we go through the week? Because if I'm going fairly fast through the chapter, I'll probably take a step back and just give you a few questions or something to do on Friday. And if I'm not going as fast as I want to go, I'll do a class. So can I let you know on Wednesday or Thursday, if that's okay? Right. Okay. So as I say, guys, right, all these identities here on page 13, right, you can take them as gospel. There's a few you have to prove, right? Okay, see these 2 up in the corner, you need to be able to prove these, okay? I'll be giving you a list though of proofs that you need to learn, okay? And we'll be spending a few days going through all those proofs when we get back, if we get back, right? Okay, so these 2, for the moment, you have to learn how to prove these, right? Then at any stage you could be asked to prove anything, but you can take everything on these 3 pages as gospel. So anything that's written on these 3 pages, you can accept it as the truth, right? So the first thing we need to learn are these 3 new identities here, girls. Cosec A is the same as 1 over sine, okay? You learn these, or sorry, you don't learn these, they're written in the log tables. Cosec A is 1 over sine, sec A is 1 over cos, and cot A is 1 over 10, okay? Just 3 new identities, right? 3 new ratios, right? And they're written in here, so you don't need to remember them, they're written up there, okay? Is that right? So the first thing we're going to prove is that tan A equals sine over cos. And tan A equals sine over cos is written up here, right? So we're just going to prove it. How are we going to prove it? We're going to draw a right angle triangle, right? We're going to, I call this line X, this line Y, and this is the hypotenuse. Here's my right angle, okay? Yeah. So X, Y, angle A, hypotenuse, right? So sine of A, girls, would be opposite over hypotenuse, which is opposite would be X over H. Okay? Right? Cos of A would be Y over H, wouldn't it? Adjacent over hypotenuse would be Y over H. Okay? So then if I get sine over cos, so sine over cos, right, okay, which is what I'm saying 10 is, but I'm just going to prove it now, would be sine A, which is X over H, divided by cos A, which is Y over H. Okay, so I'll just go up here. So that's X over H divided by Y over H. That's what that means. Okay? Rules of probably haven't divided fractions since primary school, but the rule is you change the sign to a multiply and you turn the second fraction upside down. So I'm going to make a multiply a dot, so we don't think it's an X, right? And we're going to turn the second one upside down, sorry, divided by Y over H. going to turn the second one upside down, it becomes h over y. So it becomes multiplied by h over y. Okay? The h's cancel, that's equal to x over y, and x is the opposite, and y was the adjacent, so that's equal to tan of a. So I've just proved that tan of a equals sine over cos. Okay, so I got sine, got cos, divided one by the other, ended up with x over y, which is opposite over adjacent, which is tan of a. Okay, so that's the first proof you have to know. Ready?
Miss, what did you take for 2 seconds?
Yeah, I'll give you 2 seconds and someone was asking me something, sorry.
Yeah, why did you flip the H and the Y around?
Because, you know, the division of fractions, you learnt it in primary school. Division of fractions, you change the sign to a multiply and you flip the second one. So, instead of dividing by a half, it's the same as multiplying by 2 over 1. Instead of dividing by 3/4, it's the same as multiplying by 4 over 3. Right, we learned that in primary school, okay? Probably haven't heard about it since because we have a calculator, but yeah. Is that right? Are we okay? Can I take it away?
Miss, does the last thing say tan A?
Tan A, it does, yeah. Sorry, writing very bad.
Thanks.
Right, okay, we okay? Right, the next bit I want to go on to so is, right, there's another identity on the top corner, that thing I'm now going to prove, that's cos squared A plus sine squared A equals 1. Okay, so it's an identity, it's written, and you can take it as gospel once we've proved it. Okay, so it's written up there in the corner, right, okay, but we to prove it. So remember our unit circle, right? We did it at the back, at the start of trigonometry 1, right? Okay, so the unit circle has a radius of 1, okay? And this is angle theta in there, right? Okay, so every point on the unit circle has the coordinates cos theta, sin theta, okay? We learnt that back in trigonometry 1, okay? It's called the unit circle. I should probably unit circle. So this is only true for the unit circle. A unit circle has a radius of 1 and a centre of 0, okay? So then what I'm going to do is I'm going to get the distance between cos theta, sin theta, that point, and 0, 0, the origin. So this is this is x1, y1, and this is x2, y2. Okay, so just fill in your distance formula from coordinate geometry. So x2 is cos theta, minus x1 is 0, to be squared, plus y2 is sin theta, minus y2 is 0, to be squared. Okay, but you know the answer is 1. How do you know the answer is 1? Because that's the radius of the circle and it's the unit circle that you've just drawn. So you know the answer is going to be 1. Okay? So then squaring that out, that's the square root of cos theta minus 0 is just cos theta, so that's cos theta to be squared. Remember, we write that as cos squared theta. That's just cos theta squared. Right? Here, this is sine squared theta. Is that okay? So remember, cos theta to be squared is cos squared theta, right? Sine theta to be squared is sine squared theta equals, and the answer is 1. Then square both sides, so square both sides. So squaring both sides, so on this side when you square it you just lose the square root sign, and when you square the other side, 1 squared is 1, you still get 1, which is what you were trying to prove. So that's going to be the most useful equation you'll use in this chapter. Okay, right, what I need to do there is, right, you know the way cos squared plus sine squared theta equals 1, this also means that cos squared theta, these are very handy, also, cos squared theta equals 1 minus sine squared theta, and you could leave sine squared theta, just rearranging that equation that you've just proved, right? Okay, this, you'll be using these a lot in your proofs. You'll see what I mean in a few minutes, okay? Right, so sine squared theta equals 1 minus cos squared theta, just rearranging that thing you've just proved, okay?
Miss, how many proofs do we have to do?
There's, I don't have a number for you, but there's lots and lots and lots, but I do have them all, a list of them all typed out for you, which I'll give to you when we get back to school. I'll give you the list all typed out, and we'll go through every single one of them so you know which ones to learn and stuff. Okay? So we left out most of the proofs when we were going through the chapters. We left out most of the proofs, okay, but when we're finished, I'll take about 3 days and I'll do every single proof from start to finish, and give you a list and you'll go off and learn them. Okay? I don't have a number, okay, but there's probably about 20, give or take. There's also 3 theorems that we didn't do yet. Not that we didn't do, just didn't do yet. Okay? And finally, the last example, the last equation on that page, this one that I've shown you. So look, I proved tan theta, I proved cos squared plus sine squared equals 1, and now I'm going to prove this one here. See this one? Sec squared A equals 1 plus tan squared A. Okay? So I'm now going to prove that one. Okay, I covered it over, can I go? Screen? Anyone? No. All okay? Right, okay, so this proof, it's the other equation that's up on the left hand side, okay? So what I'm going to do is, to prove that, right, I'm going to start with what I've just proved, because I know that this is true. Sine squared theta plus cos squared theta equals 1. Just learned that, right? Okay, so this is already proved. So this is a fact. My internet connection is unstable. Great. Am I okay? Am I still glitchy? Because I just got a message saying my internet connection was unstable. I'm still glitchy?
Yep, you're
Yeah. Right, okay. So this is already proved. Okay, so I'm going to divide everything by cos squared theta. Okay, so I'm going to start here, sine squared theta. I'm going to divide that by cos squared theta. The second one, cos squared theta, I'm going to divide that by cos squared theta. equals 1 all over cos squared theta. So I just basically took every single term there and divided it by everything. Remember, if you do to the whole line, you haven't changed it. Okay? So this is the same as sine theta over cos theta, all to be squared. Cos squared theta over cos squared theta is 1, right? 1 over cos squared theta is the same as 1 over cos theta to be squared. So I know from here, right, that sine over cos is 10, so this is 10 squared theta. The 1 stays the same, and 1 over cos, again, from this page, is sec squared theta, right? Sec squared theta, which is what they wanted me to prove. Okay, it's just written in different order. 10 squared plus 1, 10 squared plus 1 equals sec squared theta. So that's it proved. Okay, then everything after that, guys, is stuff you haven't seen before. But the stuff you haven't seen before, you can use any identity on this page to prove it. So we proved the two identities up here in the corner. We proved this one, right? And everything else, you take everything as truth now, right? Everything here is usable, right? Okay, so you might be asked to prove stuff you haven't seen before. So, for example, you need to prove that sine theta tan theta plus cos theta equals sec theta. Okay, right. So what you do is you pick one side and you work on it. So I'm going to pick the left hand side, and I'm going to turn the left hand side into the right hand side. Okay? Anyone make a suggestion? What will I do first? Sine theta tan theta plus cos theta. I'm going to change one thing. What am I going to change? I'll give you a hint. Tan theta, what are you going to change that into? What's tan? Sine over cos. Okay? So sine theta and changes to sine theta over cos theta. Okay? Because as I said, anything on this page is usable, and that's the first equation on this page. So there, I've just changed it into that. Okay? So plus cos theta. No, I'm not going to touch the right hand side. I'm going to keep working on the left hand side, and I'm going to turn it into sec theta. So once I turn it into sec theta, my job is done. Okay? So multiplying out here, sine squared, sine theta by sine theta is sine squared theta over cos theta plus cos theta. Okay, so I have a fraction and not a fraction. The minute you have a fraction, guys, doesn't matter what branch of maths you are at or what level of maths you're at, you always get common denominators. So common denominator is cos theta. Okay, so this will be sine squared theta. Do you know what, I say I'm after writing this down wrong, because I'm going to prove it's... No, I haven't. It's fine. 1 into cos theta goes cos theta times cos... Sorry. Oh yeah. That would be 1 into cos theta goes cos theta, so that's cos theta by cos theta, which is cos squared theta. Okay? So 1 into that goes cos theta times, multiply cos theta by cos theta, and you get cos squared theta. Okay? So we just proved that sine squared plus cos squared theta is 1. So that's 1 all over cos squared theta. 1 all over cos squared theta is the same as 1 all over cos theta to be squared, which is sec squared theta, which is the same... Oh, it's not. What am I doing? Oh, don't mind me. It's just 1 over cos theta, isn't it? Where did I... There was no squared underneath the line. Okay, sorry. So sine squared plus cos squared is 1. I just have a cos theta underneath the line, so that's sec theta. Sorry, I got carried away there. Right, okay? So with these proofs, girls, you'll have never seen them before, right? And if it takes you more than 5 lines, you're missing something, so go back and start again. They're normally quite short, so they're no more than 5 lines long. So if you're going into a second page of your proofs, right, you've missed something, go back and start again. Okay? Right, I'm going to do a few of these to kind of get you into the way of thinking of them. Okay? So, can I go?
Miss, will you just explain what you did in that last part?
Here, right?
Like with the sine plus cos, where did they go?
Sine squared plus cos squared theta is the identity. I said everything here is usable, and the first thing up there in the right hand corner, sine squared plus cos squared equals 1. See it? Cos squared plus sine squared is 1. Do you see that identity there?
Oh yeah.
Yeah. So instead of that, right, okay, I wrote 1. So they were written cos squared plus sine squared in the book, but sine squared plus cos squared is 1. Right? Okay? And underneath the line I have a cos theta, and then 1 over cos, also on that page, 1 over cos is sec. Okay? So that's sec theta.
Thank you.
Okay? It'll take a while to get into these, but once you get into these, girls, I love these. I could do these all day. I just love them. Especially when they don't work out and I have to do it 14 times. I just love it. Right? Okay? Right. Can I move on? Example 2. So I want to prove that sec A minus sine A tan A equals cos A. So you work on the left hand side and turn the left hand side into the right hand side. So don't do anything with that. Basically I'm going to work on the left hand side and I'm going to manipulate it until I just end with cos. Is that okay? So the first thing is sec A. So off you go to your table and you go sec A is 1 over cos. Okay, so sec A is 1 over cos A. Then I have a minus sign. Then sine A is here, right? I'm going to turn tan into sine over cos. So that's sine A over cos A. Okay? I'm just working on the left hand side. That's my answer. So I'm just going to keep working until I get that answer. So multiply into the bracket cos A. Here, sine A base sine A is sine squared A over cos A. Okay? Fractions get a common denominator. Look, they're over the same thing. I really don't have to, there's no work there to be done to get a common denominator. I'm just putting them all over the one line. So that's 1 minus sine squared A. And if you manipulate, remember when I did cos squared plus sine squared equals 1, I said cos squared was 1 minus sine squared. So look, 1 minus sine squared is the same as cos squared A. And cos squared A all over cos A. So that's like x squared over x is just x. So cos squared A over cos A is just cos A, which is what I got out there. Okay? And as I say, about 5 lines. If you've gone into the second page, you've gone wrong. You've missed something. Go back. Right? Okay? Next one. Ready? I go?
Yeah.
Right? Example 3. Right? So I need to prove that that equals, no, is that 10 squared theta, sorry, rubbed out there on me, equals 10 squared theta. So all of this on the left hand side equals 10 squared theta. Right, suggestion. We need to see 2 sets of brackets. What's the obvious thing to do?
Multiply them.
multiply out. So take the first term, multiply by the second bracket, and I'm writing it all out just so you can see exactly what I'm doing, plus cos theta. So I'm multiplying out the brackets up top. Underneath, I'm using cos squared theta. So multiply out, I get 1 minus cos theta plus cos theta minus cos squared theta. That's what I get on top of the line. Underneath the line, I just have cos squared theta. Minus cos theta plus cos theta cancel out. So on top, I have 1 minus cos squared theta over cos squared theta. But from, this is the most useful formula going up here. If I rearrange it, 1 minus sine squared is equal to 1 minus cos squared, isn't it? So I can change 1 minus cos squared into a sine squared theta. And remember, sine over cos is 10, so that would be 10 squared theta, which is what I got up, what I wanted to get, so I'm done. Okay, and again, as I say, 1, 2, 3, 4 to 5 lines, that's as long as they should be. Is that alright? Okay, I think that's the end of my examples. Right, okay, so what, there's loads of these, girls, in the book. Right, okay, so what I'm going to ask you to do is, right, use these, page 307, do 2, 4, 6, 8, 10, 12, 14 and 16. Okay, so page 307, 2, 4, 6, 8, 10, 12, 14, 16. Right, this page, you don't need to turn this page, right? Everything you need to know is on this page. Your most important formula is up there on the right hand side, okay? But you can use anything that's written up here, right? Okay, so I'll leave you have a go at those for tonight, right? So it'll take a bit of getting into them, but do your best with them and I'll do them out tomorrow, okay? But as I say, five lines, give or take, right? Okay, 5 lines, give or take, is all those proofs should take you, okay? Is that right? Okay, so,
Could I see that last one there for a second?
yeah, sorry.
I'll just take a picture.
I'm putting up the video because there's a few people, people missing, so I'm going to put the video up on YouTube, and I'll put the link on Teams, so if you want to have another look over the class, okay? Right? Okay,
thank you.
so what you can do is, guys, once you've the homework down, will I put back the homework? Are we okay?
Will you go back to homework, please?
Yeah. So once you've the homework written down, you can head off, right? And I'll see you